A bone fragment sits in a clean room in Jena, Germany. It is small enough to hold between two fingers. It belonged to an infant, buried beneath the floor of a house in what is now southern Israel, sometime in the 12th century BCE. A researcher drills into the petroous bone, the densest part of the skull, the last place ancient DNA survives. The powder goes into solution. The solution goes into sequencing, and what comes back changes a debate that has run for over a century. But the debate itself is worth understanding, because without it, the DNA results are just numbers. With it, they are a detonation. For as long as modern archaeology has existed, the Philistines have been a problem. They appear in the Hebrew Bible as the great enemies of the Israelites, the people of Goliath, the occupants of 5 powerful cities along the southern coast of the Levant: Ashkelon, Ashdod, Ekron, Gaza, and Gath. The Bible treats them as outsiders, foreigners, people who came from somewhere else. But the Bible is not an archaeological report. It is a collection of texts written centuries after the events they describe, shaped by the political and theological needs of the people who composed them. So for a long time, the outsider label was treated with caution. Maybe the Philistines were just another Canaanite group that the biblical authors needed to cast as different. Maybe Philistine was more of a political designation than an ethnic one. Then the digging started, and what came out of the ground complicated things enormously. Around 1200 BCE, right as the Bronze Age world was collapsing, something shifted in the cities that would later be called Philistine. The pottery changed. The architecture changed. The food remains changed. Suddenly, there were Aegean-style vessels, hearth-centered buildings with layouts that looked nothing like anything else in the Levant, and a lot more pig bones. The shift was not subtle. Walk through an excavation layer from 1300 BCE, and you see one culture. Step up into the 1200 BCE layer, and you see something else entirely. The break is sharp enough to photograph. For decades, one camp of scholars said, "These are migrants," real people who crossed the Mediterranean, possibly from somewhere near Greece or Crete, and settled on the Levantine coast. They brought their pottery traditions, their architectural styles, their dietary habits. The other camp said, "No, this is cultural diffusion." Trade networks carried ideas, not populations. You do not need migration to explain new pottery. You need trade routes. You need prestige goods. You need a local population that wanted to adopt foreign styles because those styles carried status. And honestly, both sides had decent arguments. The material culture really does look Aegean. But material culture travels without people all the time. We know that. The Romans did not have to move to China for Chinese silk to show up in Roman markets. The similarity could mean ships full of families, or it could mean a few merchant captains and a fashion trend. There was no way to break the tie using objects alone. Here is the thing that kept the debate locked in place for so long. Every type of evidence available before the 2010s had the same fundamental limitation. It could tell you what changed, but not who changed it. Pottery styles can be copied. Architectural plans can be learned. Burial practices can be adopted. Even the pig bones, which seemed like a strong ethnic marker because the surrounding Levantine cultures avoided pork, even that could be explained by economics rather than identity. A port city with access to maritime trade routes does not need migrants to explain a new food source. It just needs new trade partners. And the textual evidence was barely more helpful. The Egyptian inscriptions at Medinet Habu, carved during the reign of Ramses III around 1178 BCE, mention multiple groups raiding and settling the eastern Mediterranean. The Peleset, often identified with the Philistines. The Cheker, the Shekelesh, the Denyen, the Weshesh. These names appear in dramatic battle scenes, carved into temple walls, showing Egyptian soldiers fighting bearded warriors arriving in ox carts and warships. The imagery is vivid. But Egyptian propaganda is not a census. These carvings were victory monuments, designed to glorify a pharaoh, not to document the demographics of his enemies. We do not know if the Peleset numbered in the thousands or the tens of thousands. We do not know if they came from one homeland or several. We do not even know if the Egyptian scribes distinguished them correctly from other groups or lumped them together for narrative convenience. So the field spent decades arguing in circles. Each side could explain the same evidence through a different lens, and neither could definitively rule out the other. The question was fundamentally unanswerable with the tools available. And then someone opened the bones. The Leon Levy expedition had been excavating Ashkelon since 1997. This is not a small-scale dig. Ashkelon is one of the largest ancient port cities on the southern Levantine coast, with continuous occupations stretching from the Neolithic through the Crusader period, thousands of years of human life stacked in layers of mud brick and sand. Over nearly 2 decades, the team recovered thousands of artifacts, but the real prize turned out to be skeletal remains spanning 3 critical time periods. Bronze Age burials from a necropolis, the kind of structured cemetery that tells you a stable community lived here for generations. Early Iron Age infants tucked beneath house floors, a burial practice that itself signals a cultural rupture because there is no precedent for it in the preceding Bronze Age layers at Ashkelon. This is not how local people had been burying their dead. This is something new. And later, Iron Age individuals from a cemetery adjacent to the city wall, people living 2 or 3 centuries after the supposed arrival. 3 snapshots of the same city across the very centuries when the Philistines were supposed to have arrived, flourished, and become part of the local fabric. Michal Feldman and her colleagues at the Max Planck Institute, working alongside Daniel Master from Wheaton College, took 108 of those skeletal elements and attempted to extract ancient DNA. I want to sit with that number for a second. 108 bones went into the pipeline. Only 10 produced usable DNA, under 10%. The southern Levant is brutal for preservation. The heat, the humidity, the chemistry of the soil, it all degrades genetic material far faster than in colder climates. In Scandinavia or Siberia, ancient DNA studies routinely achieve success rates of 50 or 60% from skeletal remains of similar age. Here, 90% of the samples returned nothing. Every viable genome was a small victory pulled from near total destruction. The process itself is painstaking. Each petrous bone, that small, dense wedge behind the ear that outlasts every other part of the skeleton, gets drilled to extract roughly 100 milligrams of powder. The powder goes into a chemical solution designed to release whatever fragmented DNA remains. The resulting library is then screened. Only samples exceeding 0.2% human DNA and showing at least 10% deamination damage, the chemical fingerprint that confirms the DNA is genuinely ancient and not modern contamination from a researcher's glove or a storage room, made the cut. For males, nuclear contamination was estimated at a maximum of 4.3%. For all individuals, mitochondrial contamination ranged between 0 and 9%. These are the kinds of numbers that separate real results from noise. The rest were discarded. Those 10 individuals were sorted into 3 groups. 3 from the Bronze Age, carbon dated to approximately 1746 BCE to 1542 BCE, before the supposed Philistine arrival. 4 from the early Iron Age, carbon dated to approximately 1379 BCE to 1126 BCE, right when the cultural transformation was underway. And 3 from the later Iron Age, estimated from the 10th to 9th century BCE, a couple of centuries after. What Feldman's team did next was elegant. They enriched the surviving DNA fragments using a capture method targeting 1.24 million specific markers across the genome, single nucleotide polymorphisms that act like genetic signposts. Imagine a map with over 1 million pins, each representing a spot in the human genome that varies between populations. By reading which variant each ancient individual carries at each of those million-plus positions, you can place them on a landscape of human genetic diversity and see who they cluster with. The team projected those ancient genomes onto a principal component analysis, alongside hundreds of ancient and thousands of modern individuals from across West Eurasia, essentially plotting where each person falls on a vast map of relatedness. The Bronze Age individuals landed exactly where you would expect. They clustered with other Levantine populations close to earlier groups from Jordan and Lebanon, consistent with what previous studies had shown about genetic continuity in the region stretching back over a millennium. Local people. No surprise. Then the early Iron Age genomes loaded onto the same map, and they shifted. Not all by the same amount. That matters enormously. One individual barely moved from the Bronze Age cluster. Another landed almost on top of late Bronze Age Greeks from the southern mainland. The spread was enormous, far wider than you would see in a homogeneous local population. On average, these four infants carried around 14% Western hunter-gatherer ancestry, a distinctly European signature that Bronze Age Levantines had at only 2 to 9%. Genetic clustering assigned them an average of 14% contribution from a component maximized in Mesolithic European hunter-gatherers, a signal that simply does not appear at those levels in anyone from the Levant before this moment. The formal statistical modeling went further. The best fit placed roughly 43% of the early Iron Age ancestry as coming from Bronze Age Crete. Alternative models fit nearly as well, using modern Sardinians at 35%, or Bronze Age Iberians at 22%. Different source populations, different proportions, but the same conclusion. Something European had entered the gene pool of Ashkelon right when the pottery and the pig bones and the new architecture appeared. And yes, I double-checked this. The variation within the early Iron Age group is one of the most telling details. If these four infants were children of a single homogeneous migrant community, they would cluster together tightly. They do not. They scatter across the principal component map from near Levantine to near Greek. That scatter is exactly what you would expect from a recently mixed population. Some children of first-generation migrants who married other migrants. Some children of migrants who married locals. The mixing was ongoing when these infants were buried. We are looking at a community in the middle of a demographic transition. If you have been watching this channel for a while, you know how rare it is for ancient DNA to line up this cleanly with the archaeological record. Usually, genetics and material culture tell different stories. A population can change genetically without any visible change in pottery, or pottery can transform while the gene pool stays put. Here, they converged. The cultural shift was accompanied by real people moving in. But here is where the story takes a turn that I think is far more interesting than the migration itself. And this is a good moment to mention if you are the kind of person who cares about ancient DNA evidence and what it actually means rather than what headlines say it means. That is exactly what this channel tries to do. We are working on several more pieces about Bronze Age genetics in the Eastern Mediterranean, and subscribing is the best way to make sure you see them. When the team loaded the later Iron Age genomes, the ones from the 10th and 9th centuries BCE, roughly 200 years after the Philistine arrival, they expected to see something, some residual European signal, some diluted but detectable trace of the migration. 2 centuries is only 6 to 8 generations. In population genetics terms, that is not very long. A founding migration should still be visible. There was nothing. The later Iron Age individuals were genetically indistinguishable from the Bronze Age population. Not similar. Not mostly local with traces of European. Indistinguishable. The formal F4 statistics showed symmetry between the later Iron Age group and the Bronze Age group when tested against every reference population in the dataset. The European component had vanished completely. Within no more than 2 centuries, a detectable migration event left no lasting genetic footprint. The Philistines, genetically speaking, had been absorbed. I need to be careful about how I frame that, because the word absorbed does a lot of work and can point in different directions depending on the mechanism. Let me walk through what this actually means, because there are 3 layers here, and each one matters. First, what the evidence shows. The early Iron Age genomes carry a European-related component that the Bronze Age genomes do not. This is not ambiguous. It appears in the principal component analysis, in the clustering, and in the formal statistical tests. Multiple independent methods converge on the same signal. It appeared, it was real, and then it was gone. Second, what this rules out. It rules out the idea that the Philistines were a large, genetically dominant population that swamped the local gene pool. If they had been, their genetic signal would have persisted. You cannot dilute a majority into invisibility in 2 centuries. The math does not work for a massive colonizing force. What it suggests instead is a smaller migrant group, possibly an elite or a founding population, that was culturally influential but numerically modest compared to the surrounding Levantine population. Think less Roman conquest, more Norman conquest, a small ruling group that transformed culture without replacing the population. Third, what this implies. And this is the part that I find genuinely stunning. The Philistines maintained a distinct material culture for centuries after their genetic distinctiveness had dissolved. They kept making Aegean-influenced pottery. They kept their architectural traditions. They kept eating pork in a region where their neighbors did not. They maintained the burial practices, the cooking styles, the spatial organization of their cities. Culture outlasted genes. Identity outlasted ancestry. The thing that made the Philistines Philistine was never really in their blood. It was in their practices, their memory, their choices. I want to be honest about how difficult it is to present the next part fairly, because the evidence supports 2 very different stories about what happened, and the paper itself does not pick a winner. Because Feldman's team is careful to present 2 possible scenarios for the genetic erasure. Scenario 1. Gradual dilution through intermarriage. The European migrants married into the much larger local population over successive generations, and simple demographic arithmetic did the rest. Picture it concretely. A founding group of migrants arrives in Ashkelon, maybe a few hundred people in a city of thousands. They marry locals. Their children are half Levantine. Those children marry locals too, because the local population vastly outnumbers the migrant descendants. Within 6 to 8 generations, the European genetic component halves and halves and halves again until it drops below the threshold of detection. The culture persists because it is taught, practiced, reinforced by institutions and memory. But the genes are swallowed by sheer numbers. Scenario 2. Population replacement. A new wave of Levantine-related people moved into Ashkelon during the later Iron Age, effectively replacing or absorbing the mixed population entirely. This is not as dramatic as it sounds. Ashkelon was a major port. Port cities experience constant demographic turnover as populations flow in and out with trade, warfare, famine, and opportunity. The later Iron Age was a period of significant political change in the region, with new regional powers asserting control. A demographic shift driven by incoming Levantine populations is entirely plausible. The statistical modeling allows for the later Iron Age group to contain anywhere from 7 to 38% early Iron Age ancestry. But, critically, 0% cannot be ruled out. It is possible that the Philistine genetic line was not just diluted. It may have been replaced entirely, overwritten by incoming populations, while the cultural traditions persisted like a residual signal, passed on even as the people carrying the original genes disappeared. And we do not know which scenario is correct. There is a real scholarly tension here that no amount of modeling with 10 genomes can resolve. Some researchers point to continuity in material culture as evidence that the population persisted but simply intermarried. The Philistines kept their distinctive traditions for centuries, the argument goes, which is hard to explain if the people carrying those traditions were completely replaced. You do not typically maintain foreign cooking styles and architectural layouts when the entire community has been swapped out for locals. Cultural memory is resilient, but it usually needs some thread of human continuity to persist. Others push back. They note that Ashkelon was one of the most connected harbors in the ancient Eastern Mediterranean, a place where populations cycled constantly. Cultural practices can be maintained by institutions, by trade guilds, by urban identity, even when the demographic base shifts. A port city absorbs people. That is what it does. And if Philistine identity became linked to the city rather than to a bloodline, then the culture could survive any number of demographic turnovers. A lot of you in the comments have asked whether ancient DNA can ever give us a definitive answer in cases like this. The honest answer is, not yet. Not with 10 genomes. What Feldman's study proved is that the question is answerable, but answering it will require what they call temporally dense genetic sampling, many more individuals from tightly dated contexts across multiple sites. Not just Ashkelon, but Ashdod, Ekron, Gath, and the surrounding non-Philistine settlements for comparison. 10 genomes opened the door. Hundreds might walk through it. And there is another layer of uncertainty here that I think does not get enough attention. The paper notes that the best proxy for the incoming European gene flow is Southern European, but the exact source population remains unclear. Crete fits well statistically. So does Sardinia. So does Bronze Age Iberia. These are very different places, separated by thousands of kilometers of Mediterranean Sea. The researchers are explicit about this limitation. Because of geographical and temporal gaps in the ancient DNA record, the populations used as proxies may not represent the actual source. The real homeland of the Philistine migrants could be a population that has not yet been sampled, a Bronze Age group from Western Anatolia, or Cyprus, or some coastal community that no longer exists as a distinct genetic entity. This connects to a broader question about the Sea Peoples themselves. The groups described in Egyptian inscriptions at Medinet Habu, the great temple where Ramses III carved his victories into stone, list multiple names: Peleset, Cheker, Shekelesh, Denyen, Weshesh. These may not have been a single people. They may have been a coalition, a wave of displaced populations from across the Mediterranean, driven by the cascading collapse of the Bronze Age palace economies, each group carrying a slightly different genetic profile depending on where they came from. The variation that Feldman's team found in the early Iron Age genomes, that wide scatter across the principal component map, might be the signature of exactly that kind of mixed migration. Not one homeland, but many. Not one fleet, but a slow, chaotic flow of displaced communities converging on the same stretch of coast because the old world behind them had stopped functioning. Think about what was happening across the Eastern Mediterranean around 1200 BCE. The Hittite Empire in central Anatolia collapsed. The Mycenaean palace centers in Greece burned or were abandoned. Egyptian power contracted. Trade networks that had connected the entire region for centuries fell apart within a generation or two. When an entire economic system collapses, people move. They do not move in neat, organized columns. They move in waves, in fragments, in desperate improvisations. Some end up in places they never intended to reach. The Philistines settling in Ashkelon might not have been a planned colonization. It might have been survival, and that makes the genetic erasure even more poignant if you think about it. A displaced people arrive at the edge of a collapsing world. They build something new. They raise children. They bury their infants beneath their house floors, a practice from wherever they came from, a small act of cultural memory in a foreign land. And within 2 centuries, the land absorbs them. Not violently, not dramatically, just quietly, through the arithmetic of marriage and birth in a place where the locals always outnumbered the newcomers. And that brings the story into the present. Right now, across the Eastern Mediterranean, Ancient DNA labs are processing skeletal material from sites that were inaccessible or unsampled a decade ago. Cyprus, Crete, coastal Turkey, the northern Levant, the Aegean Islands. Each new genome narrows the possible origins. Each new sample from a tightly dated context makes the disappearance of the Philistine genetic signal either more or less remarkable. Feldman's own paper ends with a warning that reads almost like a mission statement. Transient gene flows, the kind that appear and vanish within a few generations, can be completely invisible unless you happen to sample the right window of time. Think about what that means. How many other migrations have occurred in human history? Real movements of real people that left no genetic trace because they were absorbed too quickly. How many founding populations arrived somewhere, transformed the culture, and then vanished into the local gene pool before anyone could record their DNA? The Philistines were only caught because 4 infants were buried under 4 houses in one city during one narrow century. 100 years earlier, the signal had not yet arrived. 200 years later, it was gone. The entire visible window of this migration, in genetic terms, is about the width of a single long human lifetime. If the Leon Levy expedition had excavated a different part of the site, or if those particular houses had been built 20 meters further east, or if the 4 infants had been cremated instead of buried, we would have no genetic evidence that the Philistines ever came from Europe at all. The archaeological debate would still be unresolved. The diffusion camp would still be arguing that no migration was necessary. And somewhere in the soil of the southern Levant, there are bones that belong to the generation in between, the generation where the mixing was happening in real time, where a child might have carried half Aegean and half Levantine ancestry and never known those were different things. Might have played in the streets of Ashkelon speaking whatever Creole language was forming between the newcomers and the locals. Might have eaten pork at home and local grain bread at market and thought nothing of the difference. We have not found those bones yet, but for the first time in the history of this question, we have the tools to read them if we do.